Welcome to the Consul product updates. To kick us off, I wanted to spend a little bit of time talking about what brought us to the idea of Consul and the approach that it takes, given that it's a relatively unique product. And I think what it goes all the way back to is really the Tao of HashiCorp, which is a document we published around some of the essential kind of design philosophies we have for the whole portfolio, right? This includes things like our natural workflow over technology orientation, right? And what we mean by that is really focusing on what's the core workflow problem, but making sure that the tool is pluggable to different technologies, right? In Consul's case, for example, we don't really care if you're running on-premise or if you're running in cloud, if you're running on bare metal, virtual machine, containerized environment, etc. The actual environment, the platform, the technologies, Mac, Windows, Linux, etc., is designed to be pluggable against sort of a common workflow, right? And that's an approach we take in sort of all of our products. A different really important Tao for us is this idea of immutability, right? And when we talk about immutable infrastructure, it's really this notion that once I create a particular version, right? I have my version 1 server, for example, that I don't modify it in production anymore, right? I boot it from sort of this golden image that describes version 1, and then that's it, right? And if I wanted to deploy a version 2, I'd create a new golden image that describes version 2. I'd boot a server in that sort of image, and I never touch it again, right? So in this sense, it's immutable. We don't mutate it once it's been created. So this was always kind of a core ethos of HashiCorp from the very beginning. And I think if you go back to sort of circa 2013, right, to kind of put yourself into the realm of the tooling that existed, really a world that was heavy on things like configuration management, right? So the most common practice was you deploy a server, let's say a web server, and you want that web service to know the IP address of your API service or your database so that it can connect to it upstream. Probably the most common practice at the time was really you'd run Chef or Puppet or Ansible to update basically the IP address of that upstream service, right? So great, I deploy my web service, then I run Ansible, and say, great, the IP address of my database is 10.0.0.5, as an example. And so I think very early we sort of asked ourselves, okay, what would it take for us to get to sort of an extreme immutable view, right? To get to a point where I can deploy an image and with nothing else, no additional configuration management, no additional kind of convergence run, I could have that discover and connect to its upstream services, API services, databases, etc., without needing to run any additional configuration management, right? That was sort of the original problem, was really how do you think about kind of microservices in an immutable architecture, right? Considering that these things are dynamic. And what I mean by that is one option would be to bake the IP address into the machine image, right? So I can hard code the IP address of the database, let's say, in my web server's image, so when it boots, that IP is hard coded. But we didn't want to do that because then it defeats sort of being able to have a dynamic ephemeral infrastructure, right? If my database fails and it comes up at a different IP, or if I'm auto-scaling a service and IPs are coming and going, that would be a very brittle approach. So we didn't want to do something that was like a hard code. And so we really looked at this problem and said our first approach to this was, what if we could do something using a pure peer-to-peer gossip-based mechanism? So the first approach to this problem was building a tool that really used completely decentralized. You ran an agent on every node, and we would kind of gossip, in the true sense of sort of a gossip protocol, the IP addresses of the different services to one another, and they could use that dynamic catalog to basically figure out what are the upstream and downstream IPs, right? That was our first approach, and I think what we quickly found was it was a bit too unstructured, right? It didn't have a strong domain model of you have nodes and data centers and services, and there's health checks associated with it. So there wasn't this kind of domain model of how do these different pieces interact to one another. It kind of put the burden of that on the end user to define all of it. And by virtue of it being purely decentralized, it was hard to have a coherent view of the data center, right? At different points in time, each node would find out about a service coming and going. This is sort of fundamental part of the decentral nature of the gossip protocol. Versus if we could run a centralized server, we'd have a stronger consistency and a coherent view of what the data center looked like at any given time. So ultimately, that led us into the development of Consul. This was now in early 2014 that it was introduced, late 2013 that we started working on it, so almost 7 years ago. And the real focus was on this original service discovery use case. I want to launch a set of immutable images, right? They're going to have a Consul agent baked on it. can that Consul agent then dynamically register that node and say, great, this instance is now a web server running at IP1. The web server can then discover what's the IP of the API, of the database, of the cache, and this would be totally dynamic. So as nodes would come and go, right, or things would fail or they would auto-scale, the system would be able to handle it in a fully dynamic, elastic way, right? So that was the real focus, was really thinking about this kind of service discovery, this kind of networking automation. How does it work with a microservice and an immutable architecture? That's what we kind of strove to create in the initial version. And I think since then, we've kind of looked at Consul as being able to solve a broader set of networking automation challenges, but really that was the original inception behind the product.
Yeah, so that outlines the initial vision of Consul really well. We really wanted to solve this practical problem of an immutable image coming up and being able to join, a cluster immediately to find its database, to talk to any other dependencies it has, to get its configuration and things like that. And so when we looked at this problem, we described it broadly as a service discovery or service networking challenge. One of the things we put into the 0.1 release was a key value store. And I think that really threw people off to what we were trying to solve. I like to look back and feel it was a little bit unfortunate for us to put that key value store in there at that time, because we were in an environment where another tool called etcd came out a few months prior, 6 months prior, something like that, which was a distributed key value store that could be used to solve things like service discovery potentially. And when we put a key value store in Consul, it drew a lot of early sort of criticism in a sense, or just confusion around how Consul relates to etcd, when in reality, we never really thought we were actually in the same space. And so I sort of regret putting that key value store in there, because really what we were trying to solve was this problem that Armand brought up, which was bring up a node, make it available via DNS or the HTTP API or something like that. And that's where you could start to see the differences. We had built-in 0.1 DNS interface to find those services. Really quickly following up, we had ways to bring configuration via something like the KV into your service. And then fast forward to today, and we support many, many more use cases really focused at solving this broad service networking problem. We didn't want to build this toolkit where you could build those types of tools on top of Consul. We wanted Consul to be the solution, the final solution that made your service-oriented or microservice architecture really tick and work together. And so that's why Consul today has so many of these features out of the box. And to talk about all these features in detail, I'd like to introduce Nina Pemaraju, the Director of Product Management for Consul.
Welcome to HashiConf Digital 2020, and thank you Armand and Mitchell for that look back into Consul, one of HashiCorp's most downloaded tools since 2014 with a large community of users. Earlier this year, HashiCorp joined CNCF to help users of CNCF technologies becoming successful with HashiCorp toolset as well, and we're really excited about that association now. For those who are new with Consul, Consul is a platform that allows you to discover, automate, and secure services networking across any cloud and runtime platform. And the way we do this is three things. First, the way it works, we decouple IP addresses using service name as identity. Then we automate service networking based on logical services. And finally, we secure service-to-service traffic with identity-based security policies. There's a large number of users who have been using Consul, and you can see the numbers in the monthly downloads as well. So the three use cases that Consul then serves, the first one is service discovery and health monitoring. The second is network infrastructure automation, and the last is multi-platform service mesh. And we've typically seen Consul users follow an adoption journey that goes from service discovery to network infrastructure automation to service mesh, though there are exceptions for certain organizations that start straight with the service mesh. So let's look at the use cases deeply. The first use case is service discovery and health monitoring, which enables registering new services and having it available to others to use rapidly, reducing the time from days to seconds of new services being used. The next use case is network infrastructure automation, which enables updating manual network configuration tasks automatically and instantly, allowing for acceleration in application delivery by automating these tasks. And the third use case is multi-platform service mesh, which enables automated and secure service-to-service connections, providing insights into service performance and health, and improve developer agility by enabling self-service. Today, we are going to cover a number of updates on Consul open source, ecosystem, and enterprise. Let's start with the open source. For open source, we released a number of features in the last few releases. We released Consul 1.8 in May with our own gateway offerings to provide real technical and business value of 1, integrating new and existing apps into the mesh with ingress and terminating gateways, and 2, securely extending service networking across different data center environments with the ability to federate over the mesh gateway. These enhancements provide a way for organizations to connect their service mesh anywhere using Consul. Next, let's look at the Consul ecosystem. Consul provides a single control plane to provide consistent application networking experience across a broad ecosystem. Simplified workflows and integrations with a focus on workflows, not technologies. Network infrastructure automation within Consul enables organizations to move away from manual ticket-based approaches in dynamic IP environments to update configurations and load balancers, firewall, as well as software-defined networking devices. It provides a declarative, workflow-driven network automation using Terraform along with a partner program to build a robust ecosystem, and the tech preview of this was announced at Partner Summit at HashiCorp earlier this week. Here are some of the customers who are using Consul. You can see that this is a wide variety of customers across many different verticals as well as geographies. Now let's look at the different packages that Consul is available in. The first is what is Consul Enterprise. Consul is available as an open source for individual practitioners. For larger teams and organizations, we offer a number of enterprise features to increase application resiliency and performance and enhance enterprise compliance and governance. The platform package enables operational simplicity and platform reliability for production environment. Then when you put in the global visibility and scale module, this supports advanced network topologies and enhances performance and resiliency at scale. And finally, the governance and policy module provides standard policies around service naming, registration, ACLs, intentions, etc. The next package you can use for Consul is the HashiCorp Consul service on Azure, short form as HCS. We made HCS generally available in July of this year. With HCS, a user can provision dedicated Consul infrastructure into their Azure subscription directly through the Azure portal. This enables a team to secure application networks across AKS, Azure Compute, and on-premise data centers while offloading the complicated operational aspects to HashiCorp. The end result is a faster migration to Azure for critical workloads with the safety and security guarantees that Consul can provide in an untrusted network environment. We provide 3 HCS offerings to enable an individual or an organization of any size to easily consume Consul as a managed service. For organizations requiring complex multi-cloud architectures or strict application resiliency and organizational compliance not met by a managed service, Consul can be self-hosted and maintained by an organization using the Consul Enterprise package. And then the last package is HCP Consul. We've seen demand for cloud service offerings increase further as Terraform Cloud and HCS on Azure have become increasingly popular. Enterprises who use multiple products or for whom multi-cloud is becoming a necessity have expressed interest in platform solutions. Demand for cloud services is also rising across the application infrastructure market in general. In response to the demand and to meet the needs of HashiCorp customers more holistically, we are introducing HCP as a multi-product, multi-cloud platform. HCP will enable customers to auto-provision fully managed product infrastructure on any cloud. To date, there are over 1,000 signups and public beta of HCP Consul is available now. In summary, we see Consul being used by users to bridge the gap between applications and networks and provide progressive delivery, consistent security, and connectivity anywhere. With that introduction to Consul, let me briefly introduce you to the key new capabilities that we are making available in Consul 1.9, which focuses on providing an out-of-box day one experience for Service Mesh and Kubernetes practitioners. With that, let me hand you over to Cody Diarklin to give you more details on Consul 1.9.
All right, thanks a lot, Nina. Thanks a lot, Mitchell and Armand, for that intro. We're going to jump in and do a little bit of an overview on some of the more detailed features of Consul 1.9, and then I'm going to show you a little bit of a demo around our custom resource definitions for interacting with Kubernetes and Consul. So again, as I mentioned previously, my name is Cody Diarklin. I'm a technical product marketing manager for Consul with HashiCorp. Let's jump in. We like to pick these kind of themes whenever we release a version of Consul, and in this case, the themes we picked are control, observe, and enhance. And these are kind of larger pillars that we use when we start to describe what we've done in this release. From a control perspective, we want to control the way that applications communicate between each other in a little bit more of a fine-grained way than previously possible. Oftentimes, it's more important to understand the way something is communicating as opposed to just if it's allowed or disallowed. And we do that through application-aware intentions or layer 7 intentions. We'll dive into a little bit more detail on that in a little bit here. Looking at observe, we want to provide a better visualization around the way you see how services communicate in an environment and make it easier for you to get metrics out. And we do that through, again, service mesh visualization. And then from an enhanced perspective, we continue to drive a great first-class experience with Kubernetes, and we really want to bring in the ability to manage Consul and Kubernetes via custom resource definitions or CRDs. We're also adding out-of-the-box support for OpenShift. Taking a look at our observability capabilities in 1.9, you can see on the screen a screen capture of what our observability will look like in this release. And you can see very quickly that operators will be able to come in, hit their services, and look at a topology view and understand some of the metrics around how services are communicating between one another. We can see very easy ways to determine any sort of problems that are in place and be able to diagnose service-to-service communication problems. We're also able to capture kind of key metrics and get those out of Consul to be able to feed into other dashboarding platforms. But in this case, we're seeing some key metrics within each service directly inside of the Consul UI. I touched on application-aware intentions a little bit on the earlier slide. They're also known as L7 intentions or layer 7 intentions. And what these are able to do is look at the actual HTTP traffic of the communicating service. What is that application trying to do? What's the headers on that? What path is it trying to access? And we can allow or disallow communication based on that. So for example, you might want to say that Chrome browsers can't hit the /dev path as just a random example. We can do that via layer 7 intentions. So we're able to actually do that intention model of allowing or disallowing communication based on actual request information. These also apply to the different methods that are in place, whether it's a put or a get. Any of those things can be also applied to this layer 7 model. So this is going to be really exciting to see how we can further the way that service mesh is actually secured between the applications communicating. Personally really excited for this one because we're finally bringing the ability to manage Consul on Kubernetes in a Kubernetes native way with CRDs, so custom resource definitions. So you can see an example on the right of CRDs that apply some service default configurations and then finally set up a splitter to send some of that traffic between environments. You've seen that in a couple of my demos that I've done historically where I've used these splitters to move traffic around. And it's really exciting to be able to do that in a Kubernetes native way in this case. Also, we're adding that first-class support for OpenShift, so people who are in the OpenShift ecosystem will be able to consume Consul day one. We talk about these pillars whenever we highlight Consul, the idea of kind of progressive application delivery, zero trust application networking, and service level observability as kind of these big solution focuses of Consul. You know, it's oftentimes the phrase of service mesh gets wrapped up in a lot of buzzword, but when you start to decompose that service mesh phrase into the capabilities you get out of it, hey, do you want to be able to gradually roll out a service? Do you want to be able to send 10% of traffic to a destination as opposed to just cutting over all traffic? The answers come very quickly. Of course, those are things we want. Do you want to be able to secure all your traffic with certs on day one? Of course we do. Do you want to be able to do the zero trust networking, deny all traffic that's not explicitly allowed? Of course, why wouldn't I want that? And then finally, do you want to be able to get good visualization into the services? Yes. These are all things that like make up an actual service mesh, but they get lost in that buzzword sometimes. So we want to really focus on these three pillars as kind of solutions focus for how we're driving the story of Consul. So really excited to share that Consul is going to be in public beta as of today. So that you can go out and try Consul 1.9, take a look on consul.io, and you'll be able to pull it down. And you also heard previously that we were announcing the beta for our network infrastructure automation using Terraform Tech Preview. This allows you to take Consul and that service catalog that collects information about all of the services inside of an environment and have Terraform drive updates against those infrastructure based on the contents of Consul. So I mentioned earlier that we were going to do a little bit of a demo. We have a great session following this one with Blake and Hannah doing a deep dive on layer 7 intentions and visualization, so you won't want to miss that. So in this demo, I'm going to dive into the custom resource definitions and show you how we can use those CRDs to control the flow of traffic between different versions of applications. Before we get started, let's get a lay of the land. Here we have my Consul environment, and I have a couple of applications that are already deployed into this environment. I've got an API, a database, and a front-end service. These services are part of the service mesh currently. Let's switch over to the command line and let's take a look at our actual Kubernetes environment. If I do a kubectl get pods, we can see a couple of new entries in this environment. I have a controller and a webhook cert manager. These are used to translate the CRDs that I'm going to apply, the custom resource definitions, into configuration entries that Consul can understand. Let's take a look at our actual Consul's Helm chart configuration so we can see how this was set up. If we take a look at this configuration file, you can see I have the controller stanza and it's set to enabled. We're going to add that custom resource definition into our deployment application, which I've done here. And I'm going to add a second one for our API. So we now have our front end and our API services set up with custom resource definitions. I'll write this out and apply the configuration change to the environment. We can see both of those CRDs have been created here, a front end and an API. No changes were made to our API or front end services. Since we're going to use the ingress gateway, we'll go ahead and write our configuration file out for that. So we've applied that configuration now to Consul. And if we take a look at our services in Kubernetes, we can see our ingress gateway here. And we'll go ahead and we'll issue a while loop to check the connectivity to that service. And we can see that we're returning back the version 2 of our API. This is going to continue to run throughout this demo to make sure that we're connecting successfully. We'll go ahead and edit the v2 of our application, and we'll add in those same custom resource definitions to enable it to be able to accept traffic. We're going to set up a new custom resource definition that's going to map out to the versions of our application. So our other one had a metadata version of v1. We're going to set this up to be v2. Inside this CRD, we're going to set a default of the v1, but then set up two subsets. The v1 subset, followed by the v2 subset. From here, we'll add in a service splitter. This service splitter is going to be set up to split the traffic between those two subsets. So I create one named API, and I'll set a 50-50 split between v1 and v2 of these two services. We can write this file out and we'll go ahead and apply this configuration change. You'll see that we've created a service resolver and a service splitter CRD that also map back with our previous service default CRDs. This traffic splitting is in place now, and if we take a look at our actual curling that we had done previously, we can actually see this splitting happening live. Let's switch into the command line and make the change for our v2 of our front-end service. Here I've already configured the CRDs very similar to what I did in the API tier for my front end. I've got a service resolver and a service splitter in place. This service resolver, just like the API tier, has a default of v1, and it has two subsets set up for v1 and v2, mapped to some metadata inside of those deployments for, again, v1 and v2. My service splitter is set up for the front-end service, and it's set up to send 100% of the traffic to v1. This lets us apply the configuration change, and still send all our traffic to the original destination just to validate that it's configured correctly. I've applied those configuration, and we can see we've also deployed out the V2 of our application here. This lets me deploy both my CRDs as well as my application at the same time. So when this is deployed, the running state is updated automatically. We can see the front-end service is still coming up. I've got 6 nodes up, and if I go back to the services view, it's still erroring out. It just takes a few moments to come back to life. And we're good to go. If I go back into our application and refresh, we should see the old version of our application still. It's great. And we're still connecting successfully. We'll switch back in, and we're going to go ahead and change that splitting configuration to send traffic to the new service. We already showed a gradual switch over, so I'm going to go ahead and switch all traffic over to the V2 on the fly. So I'll write this out and apply the configuration change again. We can see that CRD was configured for the splitter while the other 2 were unchanged. And if we switch back into the API and hit refresh, we can see the new version of our application welcoming everybody to HashiConf Digital. In this demonstration, we've shown how our new custom resource definitions for Consul allow us to pair our configurations for communication alongside our applications. In this demo, we showed how we could move the API tier to a version 2, all while keeping traffic intact. We then showed doing the same thing for our front-end service and brought, again, those configuration files right alongside our application deployment. When we did our application deployment, we were able to watch live as that traffic changed and as we were able to roll out the new version of the service. I'm really excited for these custom resource definitions to come into play, and it allows Kubernetes administrators to manage their service mesh in a way native to them. We care a lot about making sure that we can adapt to the workflows that our customers are using inside of these platforms, and I really think you're going to enjoy using CRDs to manage Consul. I'm really excited also for you to check out the sessions that are following up this one. Blake and Hannah have a really great session around Layer 7 intentions, as well as visualization of the platform. Hope you enjoyed this demo. Stay tuned for more at HashiConf, and have a great day.